Now students, let us understand pressure. Pressure is produced when a force acts on an object. Now in image you can see nail and wooden plank. Now try to push a nail by its head part. Now again in second case, try to push a nail with its pointed end. Apply same force on both the nails. Now when we are going to press it, what do you think? Which will go inside the wooden plank? Head part or pointed end? So you will notice that the pointed end of the nail is going inside the wooden plank. Why? Because head part, it is occupying larger area on wooden plank, so there will be a less pressure on it. So it will not go inside the wooden plank. Whereas the pointed end occupies smaller area on a wooden plank. So as it occupies smaller area on wooden plank, so there will be a larger pressure on it. So it will go inside the wooden plank. So pressure is a force acting on a unit area of an object, where P is the pressure, F is force, and A is the area of contact. So pressure is equal to force upon area, or in short what we can say, P is equal to F upon A. The standard unit of measuring force is Newton, that is capital alphabet N. And the standard unit of measuring area is square meter, or we can say meter square. So the standard unit of measuring pressure is Newton per square meter, that is N/N square, which is also called Pascal. Application of pressure. In first image you can see that heavy truck is fitted with 6 to 8 wheels. Now this wheel increases the area of contact on which the weight acts. Hence it reduces the pressure on the ground. So larger the area of contact, less will be the pressure on the ground. Second image you can see the cutting edge of knives, blade, etc. are sharpened. As the cutting edge is sharpened, the area of contact decreases. Hence pressure exerted by them increases. Thus larger pressure cuts the object easily. So smaller the area of contact, larger will be the pressure on it. Third, you can see a school bag has wide straps made up of thick cloth, so that the weight of the bag may fall over the large area of the shoulder of the child, producing less pressure on the shoulder, making it more comfortable to carry the heavy school bags. So as it occupies the larger area of the shoulder, so there will be a less pressure on child shoulder to carry the heavy bags. Next you can see the foundation of high-rising building are kept wide, so that they exert less pressure on the ground and do not sink into it. So larger the area of contact, so there will be a less pressure on the ground. Next you can see the image of army tank. You will see the wide steel belt is provided over the wheels of army tank, so that they exert less pressure on the ground and do not sink into it. So again, larger the area of contact, so less pressure on the ground. Skiers use long flat skis to slide over the snow. The larger the area of the contact, the lesser is the pressure on the snow, enabling the skiers to slide over the snow without sinking in the snow. So again, the larger the area of the contact, the lesser is the pressure on the snow. Now students, let us discuss about pressure exerted by liquid. So in order to understand this, let us go through the activities. So first activity, aim is to show that liquid exert pressure on the base of the container. Things needed: a transparent glass tube, rubber balloon, thread. Method: take a transparent glass tube, open at both the ends. To one end of the tube, tie a rubber balloon. Now hold the tube in a vertical position and pour some water into it. Observation. What you are going to observe? The rubber balloon bulges out. Now pour more water in the tube. You will see that the size of the balloon bulging more. It is increasing more. So what we have concluded? The liquid exert pressure on the base of the container in which they are put. Second, pressure exerted by the water at the bottom of the container depends on the height of its column. More is the height, more is the pressure, and vice versa. Second activity shows that the liquid exert pressure on the wall of the container. Things needed: a glass tube with a side opening, rubber balloon, and thread. Method: take a transparent glass tube with tap-like opening on its side. Now tie a rubber balloon to the opening. Hold the pipe in the middle and keep it in a vertical position. Pour some water into the glass tube. Now what you are going to observe? You will observe that the rubber balloon bulges outward. Here it will bulges out in sideways. Pour more water into the glass tube. The rubber balloon bulges more. So what we have concluded? That liquid exert pressure on the wall of the container. So sideways pressure exerted by a liquid on the wall of the container is called its lateral pressure. This activity shows that liquid exert equal pressure at the same depth. Things needed: plastic bottle and adhesive tape. Method: take an empty plastic bottle, make 4 holes all around near the bottom of the bottle. Apply adhesive tape over the row of holes. Fill the plastic bottle with water. Now remove the tape. What you are going to observe? You will observe that the jets of water comes out of the holes, fall at the same distance from the bottle. So what we have concluded? Liquid exert equal pressure at the same depth. This activity shows that pressure increases with the depth. Things needed: plastic bottle and adhesive tape. Now take an empty plastic bottle, make 3 holes at different heights. The 3 holes are of equal diameter. Apply adhesive tape over all holes. Now fill the bottle with water. Remove the adhesive tape. Now what you are going to observe? You will observe that on removing the tape, the water from the uppermost hole is found to travel at the shortest distance from the base of the bottle. The water from the middle hole goes a little farther away from the bottle, whereas water from the lowermost hole comes out farthest of all. So what we have concluded? Pressure of a liquid increases with the depth. Pressure at the top will be low, pressure at the middle will be medium, and pressure at the bottom will be high. Application of liquid pressure. You will see that the wall of dam is made thicker at the bottom. Why? As we have discussed in the activity, that water pressure increases with the depth. So the wall of the dam is made thicker at the bottom. A thicker wall can withstand a greater pressure exerted by the water at greater depth. Second image, you will see water supply tanks. Now water supply tank is placed at high place in the building. Why? Because the tanks are placed at a greater height, the pressure of water will be large enough to force the water to reach the taps of the houses. Now students, let us understand about atmospheric pressure. The layer of air surrounding our earth is called atmosphere. The air has weight, so it creates pressure on the objects below. The pressure exerted by the air due to the weight is known as atmospheric pressure. The atmospheric pressure on the surface of Earth is more, whereas the atmospheric pressure on high altitude, that is on high mountains, are less. So as atmospheric pressure on surface of Earth is more, then why we are not feeling it? This is because the pressure of the blood in the blood vessels and other fluids present in the body balance out the atmospheric pressure. Now students, let us understand the existence of atmospheric pressure. Things needed: a tin can, cork, burner, some water and mastic. Method. Now take an empty tin can. For an empty can, the air pressure inside and outside is the same. Put some water in it. The tin can is heated by using a burner to boil the water so that steam is formed. The steam expels, or we can say pushes, all the air from inside the can, so that when water is boiling there is no air inside the can. The whole tin can is filled with steam. Now fit a tight cork in the mouth of the tin can and heating is stopped. Now pour cold tap water on the hot tin can. You will find that on pouring cold water the tin can collapses inwards, as if a large force acting on it from outside has crushed it inwards. So from this what we have concluded? So this experiment shows the existence of large atmospheric pressure around us. Now students, let us understand one more activity which shows the presence of atmospheric pressure. Things needed: a glass tumbler, a piece of thick card and some water. Method. Take a glass tumbler filled with water and covered it with a piece of thick card. Press the card hard so that there is no air in the glass tumbler. Now keeping the card in a position with one hand, we invert the glass tumbler full of water. The hand supporting the card is then withdrawn. Now what you are going to observe? You will see the card does not fall because the atmospheric pressure acts on the card in the upward direction and holds the card in the place. The upward atmospheric pressure acting on the card is greater than the downward pressure of water on the card. So again this experiment shows the presence of enormous atmospheric pressure around us. The atmospheric pressure is maximum on the surface of the earth. When we go to high altitude, say a high mountain, then the atmospheric pressure decreases. The mountaineers suffer nose bleeding at high altitudes because at high altitudes the atmospheric pressure is much lesser than our blood pressure. Due to this, some of the blood capillaries burst and blood comes out through the nose of the mountaineers. An astronaut wears a special space suit which maintains the normal atmospheric pressure for his body, since there is no atmosphere outside the earth. Now students, let us discuss the application of air pressure. So first is drinking straw. When we suck air at the upper end of the straw with our mouth, the pressure of the air inside the straw is reduced, but the pressure acting on the surface of fruit juice is equal to that atmospheric pressure. So the greater atmospheric pressure acting on the surface of the fruit juice pushes the fruit juice up into the straw to our mouth. Second is syringe. When the nozzle of the syringe is dipped in a liquid and its position is withdrawn, the pressure inside the syringe is lowered. The greater atmospheric pressure acting on the surface of the liquid pushes the liquid up into the syringe. Last is rubber suction pad. The rubber suction pads are used on the walls to hang clothes and calendars. When good quality rubber suction pad is pressed against the wall, the air between the suction pad and the wall is forced out, reducing the pressure inside. The outer atmospheric pressure, being greater, pushes the suction pad firmly on the surface of the wall. Thank you.